Hello, everybody. My name is David. I'm a grade 12 student at Blythe Academy, and today we're venturing into the exciting world of physics, discussing the three concepts, which are circular motion, gravitational force, and waves. So you all could just sit back and enjoy this session. Okay. Okay. So first off, we have circular motion. Now imagine you're on a roller coaster coming through a loop. Have you ever wondered why you feel like you're being pushed outward? Well, that's not magic. That's because of centripetal force. Now, if you don't know what that is, it is a force directed toward the center of the circle, keeping an object in a circular path. Now, at the top of the loop, the centripetal force is provided by a combination of gravity acting downward and the normal force from the track. Now, the speed of the roller coaster. Now, the speed of the roller coaster car is very crucial because the car must be fast enough to generate sufficient centripetal force to overcome the pull of gravity, especially at the top of the loop. Now here's another demo that I'll show you. Now let's say we have an object attached to a string, such as a tire swing, for instance. Now, if I swing this object, the string will provide the centripetal force. If I let go of the object, it will fly off. Why? Because of inertia. Now, if you don't know what that is, so inertia is the tendency of objects to resist changes in their motion. Now, what that simply means is that if an object is at motion, it stays in motion. If it's at rest, it stays at rest. All right. Now let's do a bit of calculation while we're at it. Now, let's take a roller coaster for example. Now let's say we have a 500 kilogram roller coaster car going through a loop with a radius of 10 meters at a speed of 20 meters per second. Now, in order to keep the car on the track at the top of the loop, you will have to calculate the centripetal force using the formula for the centripetal force itself. Now, under the instruction, we already have the key equation for the centripetal force, which is Fc equals m times v squared divided by r. So just for you all to get familiar with the variables, so Fc is the centripetal force, m is mass, v is velocity, r is radius. All right. So now let's plug in our values. So our mass is 500 kilograms. Our radius is 10 meters, and our speed is 20 meters per second. Alright, so we have all of our values. So now let's solve them. So 500 times 20 raised to the power 2. That is 400. So 400 divided by 10. So that is 20,000 newtons. So at the top of the loop, the car will experience a centripetal force of 20,000 newtons. All right, so that's the centripetal force. That's the example of centripetal force. Now let's continue. Let's get into gravitational force. Okay, so next up we have gravitational force. Now, what do we know about the gravitational force? Well, it's the force that binds the universe together. So what it simply means is that it helps keep us on the ground. It helps keep, for instance. And using the Newton's law of gravity. So here we have the key equation, which is Fg equals g times mass 1 times mass 2 divided by radius squared. And just for you to get familiar with this as well, so Fg is gravitational force, g is gravity. The two m's are masses, and the r is radius. All right. Now, okay. Now let's go into let's see. Now I want to show you one of the clips. I want to show you something that will demonstrate gravitational force. Now, as you can see here, I have one of the clips for the gravitational force. So you're all probably aware where this is from. So this is actually from the Coyote and the Roadrunner. now one thing you should notice here is that every time the coyote chases the roadrunner, he jumps up the he tends to accidentally jump off the cliff. He tends to jump off the cliff, and then he keeps floating in the air, and then until he comes at rest, and then he falls. He just falls. Now this is kind of now this is pretty breaking the laws of gravity, because in real life, like when if I throw something in the air, uh, let's say uh, let's say if I have if I have okay, let's say I have this party hat. So if I throw this party hat in the air, it immediately comes down. All right. So in real life, if you throw an object in the air, it will always immediately calm down. That's it. Now it's kind of now this is kind of similar. This is kind of similar to centripetal force. Only only the gravity is in motion. All right. So that's the gravity. So let's move on to waves. Okay. So last but not least, we have waves. Now one of you are probably aware of what waves are, but just for you to get informed, just for some of you who don't know what they are, so waves are kind of like messengers. Although they're invisible, and they tend to and they transfer energy. Now waves don't really move matter, but like I said before, they move energy. Now there are two different kinds of waves. We have an electromagnetic wave, and there's mechanical waves. Now electromagnetic waves are a form of radiation that travel through the universe. Such as like the vibration, for example, vibrations for instance. And then the mechanical waves, on the other hand, are waves that need a medium for propagations. Sorry. Yeah. So the example of we have so for example the mechanical waves are kind of like water drops and sound waves. And in fact, I even have those examples here right now. You can see the water ripple, and we have the sound waves, and we also have the vibration. Now, as I said before, vibration. So the example of electromagnetic wave are vibration, and the examples of the mechanical wave are like the sound wave and the water ripple. I have another example I want to show you. As you can see here, we have an explosion occurring in space. Now one thing is now funny fact that you should know is that both the water ripple and the explosion are kind of similar. Because when you think about the water ripple, you would notice that when the water splashes in the water, the ripple will spread everywhere. Just like that, when an explosion occurs, it would also spread ripples in the area. And now one thing that causes explosions is, for sure, you all are probably aware, is that if an object crashes, like if a vehicle crashes into an object or into a place, or if a bomb or a dynamite crashes on the ground, then it would create an explosion, which tends to spread ripples everywhere. All right. Those are the examples of waves. All right. So that concludes our session today. So thank you all for watching, and remember, gravity isn't just a good idea; it's the law. But circular motion, well, that's just going around in circles trying to break it. So thank you all for watching, and have a good one.